So let's graph this linear inequality into variable y equals, y less than or equal to negative x plus 1. In this case, we have to consider this inequality symbols, the symbols less than or equal to, greater than or equal to. When you have this symbol for an inequality, then you'll be using a solid line. But if you have this symbol less than or greater, you'll be using a dotted line, or it could be dash line. So dash line, I usually use dash line. And we use this for the boundary line. Yes, when you graph a linear inequalities into variables, it's not simply a line. There are so many points that will satisfy a linear inequality into variables, and that can be best represented by a plane. So it's not simply a line. The solution set here is a plane. That means we'll do shading here. Okay, so let's look at y less than or equal to negative x plus 1. There are infinite number of ordered pairs that will satisfy this inequality. So there are two steps. First step is to graph the boundary line. Your boundary line can either be a solid line or a dotted line or dash line. So let's treat this inequality as an equation for the boundary line. So let's put here BL boundary line. The boundary line can be treated, of course, as an equation here. The boundary line is represented by the equation y equals negative x plus 1. And using this equation, y equals negative x plus 1, which method is best to use? Is the table of values, intercepts, or slope intercept? It's gonna be the slope intercept, right? Because it's written in the form y equals mx plus b. So what's your slope? The slope is the coefficient of x, which is negative 1. Negative 1. Y-intercept is equal to 1. With m equals negative 1, what's your rise? Oh, we can put the negative in the rise. And how about the run? Over 1 there, so 1. All right, so if it's negative x, the coefficient of negative x is negative 1. So your slope is negative 1 over 1. Rise is negative 1, run is 1. So let us plot or locate your y-intercept. Y-intercept is 1. So where is that? 1 unit above the point of origin. There you go. So this is our y-intercept. Let's now do the rise. Negative 1, going up, going down. Down how many units? All right, that will be 1, negative 1, and then run. Right, left. Okay, right. And then what do you think is this point? 1, no, 1, 0. Yes. Oh, this one. 1, 0. All right, so the coordinates of this is 0, 1, the y-intercept, and the x-intercept is, well, we said that this is x-intercept because it's in the x-axis. So 1, 0. After that, we connect this. We connect it. Are we going to use the solid or dotted, dash line? The solid line. Okay. So solid line. Just connect this. And here we go with the boundary line. But we're not done yet, because this is an inequality. So where's the solution of the inequality? Is it only the line? There are other solutions of your inequality, and they are infinite. The other solutions can either be found here or the other half. So the solution set here is a plane. It's not only a it's not only a line. The solutions can not only be found on the line, but it can be found either on this plane or this region. So where could that be? Where could that be? In order to find which plane here represents the inequality, I mean the solution set, we can do a test point. We can we can pick any point, right? So our next step now is the test point. All right. So step one is the boundary line, and now step two is to pick a test point. Let's pick a test point, a point that is not on the line. But there is always the easiest test point that we can use. And what is that? It's the point of origin, right? So where's the point of origin? It's this. The point of origin is 0, 0. We can make use of 0, 0 as a test point if that line, if that point, I should say, is not on the boundary line. If it's not on the line, then you can use 0, 0. But what if the line intersects your point of origin? Then you can use other points. You can use a point here or here, any point. Or you can even pick a point here or here. It doesn't matter what point you want to use as long as it's not on the line. Your test point should not be on the line. And since 0, 0 is not on the line, then that's the best point to use. Otherwise, you want to make your life miserable by picking other points. Okay, so you have 0, 0. So let's have that as a test point. Why is it important to consider a test point? Because, if this point here on this side of the line makes the inequality true, then that means all the other points here will also make the inequality true, and we say that that's the solution set. But if it will make it false, then that means 0, 0 is not a solution, and also the other points are not solutions. So where are the solutions? It would be here on the other side. So let's check this test point. The test point 0, 0 means that your x is 0, 0, x, y is also 0, right? You agree? That's your x0, y0. In an ordered pair, the first element is always your x. So making use of this inequality now, let's go back to the inequality y less than or equal to negative x plus 1. When you're doing step 1, it's an equation, the boundary line. When you're doing step 2, your test point, it's the inequality now that you're going to use. So let's plug in. Your y here is 0, right? Less than or equal to negative of 0 plus 1. What's this? 0 less than 1. True or false? A bigger number should always, this inequality should always open towards the bigger number. 1 is bigger? Yes, it opens towards 1. So is this true? Yes. Now this is true. What does that mean? If that statement is true, that means that on this side, where 0, 0 is, also contains other points that are solutions of the inequality, and so we have to shade it. Okay. So shading it now, yep. Can you see that shading there? All right, let me shade it. So this would be your solution. That's your solution, including those points in the line. How about this point? Okay, let's say all points here will make our inequality true, but all points here will make our inequality, what do you think? True or false? False. Of course. But let's try to check one. Let's check one. What are the coordinates of this point here? Can you give me the coordinates of this point? Gonna be 1, 2, 3, 4, 4, 3, right? So the coordinates of that point is 4, 3. And we already know what kind of a statement we'll come up with, and that is a false statement. So let's check that. If this is the point that we use as a test point rather than 0, 0, then we have x as your 4 and your y 3. So when we plug in that one, we have y less than or equal to negative x plus 1. Your y is 3, right? Less than or equal to negative times your x, 4 plus 1. 3 less than or equal to negative 4 plus 1. Negative 2. Is that true? 3 positive number is always bigger than any negative number. So this is false. See, no matter what point you pick on this side, will always make your inequality false because those solutions, those ordered, I mean not solution, those ordered pairs are not solutions.